Right. Hello, everyone. Good morning, good afternoon, good night. Hopefully you're all comfortable at your own places. Today we have Yejin Choi. It's my great honor to introduce Yejin. She's Brett Halsell Professor at the Paul Allen School of Computer Science and Engineering at University of Washington. She's also a Senior Research Manager at Allen Institute for AI in Seattle. Yejin's research is on natural language, conversational AI, common sense knowledge and reasoning, multimodal representation learning, and AI for social good. Her work is recognized widely, including in reverse chronological order, the Marr Prize at ICCV. She has been recognized at AI's Top 10 to Watch in 2016. She has earned the Borg Early Career Award in 2018. And among her paper awards, just to name a few, AAAI Outstanding Paper Award, and just last year, ACL Test of Time Award, CVPR Longet Higgins Prize, which is kind of a Test of Time Award, and NeurIPS Outstanding Paper Award, all in the last year. Her work has been covered by the media, including Bloomberg Business Week and New York Times. In most recent news, Yejin has co-created Delphi, which is an AI system that answers ethical queries. And I was simply playing with it earlier and asked, eating a big bowl of ice cream instead of dinner, and it said it's wrong. So I think I would trust Delphi with my child. So it's reasonably working 92% of the time accurate, as reported by New York Times. Today, Yejin will tell us about her work on knowledge, common sense models, and morality. So it's great to have you, Yejin, as our keynote speaker. Your stage is yours. Welcome.
Well, thank you so much. I'm super excited to be here virtually, although I was really looking forward to join the conference physically. Oh, well, maybe next time. So the talk is going to be about how knowledge is power, especially in this new era where we see extreme scale neural models, and that extreme scale of the models do seem to invoke extreme questions, such as a journalist actually asked me whether, am I sure that we can't reach AGI just by scaling things up? Did you try GPT-3? It's so magical. And then there are some concerned voices, especially in academia. What are we supposed to do? So in this talk, I would like to discuss some thoughts toward that. And it's basically David and Goliath situation that we are facing. So let's look at what the old wisdom tells us about the art of war. So it says, know your enemy, choose your battles, and innovate your weapons. Well, in this, we do need to reinterpret this wisdom, though, in terms of the modern deep learning context. So know your enemy would mean better evaluation that has realism and scrutiny, especially adversarial and out-of-domain distribution. And then choosing our battles would mean that we can think about new tasks and leaderboards that are difficult for neural networks to cheat, larger models to cheat. And then finally, we can think about smarter algorithms and data sets as our own new weapons. So in this talk, I'm going to talk about 3 different studies, recent studies that we did. Symbolic knowledge distillation, common sense morality, and neural script knowledge. Underlying theme will be that smaller can be better, and knowledge is power, especially common sense knowledge. So starting with the first one, symbolic knowledge distillation, let me first highlight that although it's just on archive, somehow it got featured by Yannick Kilcher's channel, and his channel is very interesting. So we somehow got a lot of view counts. And before explaining what this is all about, though, let me first touch on why common sense at all. So we started thinking about it, especially given that despite human level or even superhuman level performances on a lot of leaderboards, SOTA models are brittle, especially when presented with adversarial or out-of-domain examples, making such silly mistakes that humans would never make. So this is strange, and it looks almost as if we know how to solve a data set with the deep neural network today without solving the underlying task. And there are many potentially useful ways to go forward in order to address this challenge. And one potential way might be to really think about the fundamental difference between how humans learn about the world. We actually have knowledge about how the world works, whereas neural networks today, they just learn some digitized neural representation of the world, which is not very interpretable. It doesn't have a symbolic interpretation that humans can understand. And so one big part of it might be common sense understanding about how the world works. As an operational definition of a common sense, we're going to go with this idea that it's the basic level of practical knowledge and reasoning concerning everyday situations and events that are commonly shared among most people. So we don't necessarily need to worry about whether the knowledge is shared by everyone and fully 100% agreed upon. This is more of general rules of thumb, how the world works. So for example, it's okay to keep the closet door open. It's not as okay to keep the fridge door open because the food inside might go bad. And as you see, we'll see in this talk, this is essential for humans to live and interact with each other in a reasonable and safe way, and essential for AI to understand human needs and actions better. And so in our recent work, we had Atomic and Comet as a symbolic and neural common sense knowledge model. Symbolic part, the Atomic, up until 2 years ago, we fully relied on crowdsourcing, and I'm going to talk a little bit more about it in this talk. And there's a follow-up work, Comet and Atomic. Again, these are, Atomic is a symbolic and Comet is neural representation of it. So let me show you a glimpse of what it looks like. Let's just say someone is getting someone's car repaired. Then we can imagine that as a result, that person might want to call Uber or Lyft for a ride, will probably need to pay the bill and so forth, needs mechanic or money beforehand. And so these are sort of preconditions and post conditions of our everyday events and actions. We can also reason about what money can be used for, usually paying repairs and all, but if you want it, you can also fold the paper bill into origami. So we can reason about the stereotypical use cases as well as affordances. And some of other types of knowledge are about counterfactual situations. So you cannot really get your car repaired if it's totaled, for example, and so forth. So this is only a very tiny little fraction of everything inside Atomic 2020, which included 1.3 million if-then rules described in natural language. And there are 23 different inference types or relation types, the edge types. So it's a large amount of knowledge described in open text, and it was fully crowdsourced by humans. And how much does that help in terms of teaching neural models with common sense knowledge? So it turns out when we compare Comet 2020 based on a model called BART, it's a pre-trained neural model that's more than 400 times smaller than GPT-3. So GPT-3 is so large, it doesn't even fit into the slide. With that in mind, Comet does better than GPT-3 or 2. So here higher is better. This is the evaluation based on humans on machine-generated common sense reasoning. And we find that GPT-3 is phenomenal, 73% based on few-shot example. This is really impressive, especially compared to where GPT-2 used to be, That's a zero shot, but still that jump is really impressive. But most people cannot really run GPT-3 on their machine, even if OpenAI were to share their model. So Comet is much smaller and higher quality model compared to other options right now. So since we introduced Comet and Atomic in 2000, across 2018, 19, 20, there have been a lot of creative work that makes use of either Atomic or Comet or both. So some of them investigate persona-aware conversations or figurative language understanding or interactive learning or storytelling and fantasy gaming. So given how the resource has supported a lot of creative research, we wanted to see whether we can do, we can make the common sense knowledge graph and representation better. So that's where this symbolic knowledge distillation really comes into the picture. And what we're gonna do is, because GPT-3 looked so promising in our recent analysis experiments, we decided to do something with it so that we make a smaller model that's not only smaller, but actually better. So that's an interesting goal to pursue, because usually smaller is worse in our recent literature. So is that even possible? So it can be possible. We empirically demonstrate that if you make this funnel in a particular way so that there's a critic sitting inside, and then we spit out symbolic knowledge graph, and then only then train the student to model, then at least for the in the context of a causal knowledge, common sense knowledge, we can make students that is smaller and better. This notion of knowledge distillation, first introduced by Hinton et al. A few years ago. Basically what it does is to have a smaller model that's trying to be as close to the teacher model as possible by minimizing this cross entropy. But this in practice, especially in the context of a language model, is harder because the space of output, in this case, causal knowledge, causal common sense reasoning, inference done in natural language is intractable. So, but we can easily just approximate it by some samples. So that's what we do. And natural byproduct of that sampling happens to be this common sense knowledge graph, which is interpretable to humans. So that's great. In summary, what we're going to compare is human-authored atomic to machine-authored atomic. And then the question is the resulting atomic, human-authored versus machine-authored, leads to better common sense models. So in this talk, I'm going to show you some experiments demonstrating various settings in which a machine can now do better than humans. But off the shelf, the machine-authored atomic is not as good. So if we look at this chart, the higher, the y-axis is the quantity of knowledge, so in millions. So the human-authored atomic 2020, if we only look at the causal common sense inference types, only 7 of them, then it's not as many as million in total. And green portion is good portion, black portion is bad portion. So even human-authored atomic is not perfect, but it's mostly green. Whereas if you look at GPT-3 authored atomic 10x, then it's very large, but with a lot of wrong parts. So the black is pretty significant. So then the question is, can we make it better? So what we do is we train a simple classifier critic model based on Roberta classifier. And this is not a very informed classifier, so it tends to over filter atomic 10x, but the resulting remaining portion can be kept very high quality. So if you look at the resulting atomic 10x, now it's bigger than even the human-authored atomic, And the black portion, you cannot really tell apart the difference, but actually the quality is even better too. So when we look at the original GPT-3 versus this student model, GPT based on GPT-2, even if we start to write off from GPT-3 generated knowledge as is without even filtering, somehow student is already better on its own, but that's not as good as the version trained directly off from human authored atomic. But the final version of our work, which incorporates this critic inside of this symbolic knowledge distillation business, then we end up getting the trained comet that is the best of all time, even better than the one that was trained on the human authored atomic. So this was totally unexpected that somehow machine authored knowledge base can actually be of such high quality. So to summarize, we find that not only machine authored KB, at least in the context of a causal common sense knowledge base, can be not only better in terms of accuracy and scale and value, but also it's not that the quality is good only by repetition of a similar knowledge. It turns out the machine authored atomic is also much more diverse. So this is quite interesting empirical results that I think suggest more exciting future research going forward. So that's the first part. Now I'm going to move to the second part, common sense morality in short, but it's about more broadly human values, norms, and ethics altogether. And so this impending spread of neural models, especially language models, require this revisiting the need for machine ethics. And we have this demo. You're welcome to play with the demo at delphi.allenai.org. But let me show you some representative samples to tell you what the demo is capable of. So if you ask killing a bear, Delphi says it's wrong. Killing a bear to save your child, it's okay. But maybe that's because to save your child sounds positive. So how about killing a bear to please your child? Then Delphi says it's wrong. Maybe it's all about saving your child. So how about exploding a nuclear bomb to save your child? Then Delphi says it's wrong. So here we see that moral judgments are non-trivial because there are oftentimes competing values at odds that you need to somehow balance out. And so, and by the way, the Delphi was not trained on any examples of this sort, and this is actual model output. In our original version, it was able to do relative QA as well. So stabbing someone with a cheeseburger is more morally acceptable than stabbing someone over a cheeseburger. This is a very delicate reasoning to do because stabbing someone with a cheeseburger requires naive physics knowledge that cheeseburger is too soft. So even if you were to do that, it's such a rude thing to do, but you're not going to really physically damage the person. Whereas stabbing someone over a cheeseburger requires this linguistic understanding that usually if you don't say with what, it means with a knife. So then with a knife, you're stabbing somebody presumably over a cheeseburger fight, then it's going to be very bad. So super delicate reasoning. And then you can also ask a question that requires more of a yes/no answer. So for example, it's okay to fire someone because they're gay. Then the system says, no, it's wrong. So these are all unified. And what we realize after making the system is that it's surprisingly robust against compositional situations. So mowing the lawn, it says it's expected. Late at night, it's rude, but it's okay if you live in the middle of nowhere. Again, ignoring a phone call, it's rude. Ignoring a non-phone call, that's okay. But a phone call from my friend, that's rude, but it's okay to ignore if you just had a fight with that friend. During my working hours, it's okay. Outside my working hours, it's rude. But if it's from your boss's call, then during working hours, it's wrong. But if I'm in a meeting, then it's okay to ignore, even if it's your boss's call. So as you can see, I don't know how humans do, but this is the moral judgments or social norms, judgments with respect to social norms or morals can be quite complex. It turns out because Delphi was trained on top of common sense models, some of this common sense knowledge leaks in. So mixing bleach with ammonia, Delphi says it's dangerous. Drinking milk, if I'm lactose intolerant, then it's wrong. But soy milk, then it's okay. We don't necessarily want to promote this kind of like trickier ethical dilemma problems, but we did try out of curiosity, and running over one person to save 4 people is more morally acceptable than running over 4 people to save 1 person. To be honest, though, Delphi is not robust if you ask strange numbers, not 1 and 4. That's easier for neural models to understand. Letting a sick doctor to use a ventilator, but letting an elderly patient to die versus vice versa. I don't know how I feel about it, but if I must choose between the two, I might go with the choice that Delphi made. So when in terms of a quantitative evaluation, we find that GPT zero shot is pretty much hopeless. It's doing barely better than Chen's, whereas a few shot, it does do dramatically better. But Delphi, which is much smaller, trained on human authored data, does much, much better. So, and also we did a lot of analysis in terms of fairness and justice. UN's Universal Declaration of Human Rights, it seems that Delphi agree with it 98.1% of the time. I don't know how you feel about the remaining 2%, but this is what we have at the moment. We tried our best to make Delphi equity aware. So applying to minority scholarship, if you are a woman, it's okay. Hispanic, it's good. Rich, you shouldn't. A white man, you shouldn't. A man, it's okay. Resting in the lactation room, a woman, it's okay. A man, it's wrong. A trans man, you shouldn't. A trans man with a baby, on the other hand, it's okay. So it's trained with what we call as common sense non-bank, which is 1.7 million people's ethical judgments on everyday situations. And it's combined the soup of cultural norms, social norms, ethical norms, without clear boundary across them just yet. It's our first shot approach based on 5 different already existing resources. Though of those 5, probably what mattered the most are these 2. Social chemistry, which has nearly 300,000 of normative judgments over 100,000 of real life situations that are taken from Reddit. Importantly, though, although the situations are taken from Reddit, the judgments are done by crowd workers, separately qualified and trained. And then social bias frame is the one that teaches equity. Especially social bias frames study racism and sexism and that sort of problems in human language against equity. And in fact, this is used primarily for the freeform QA version, not the binary comparison version. And it turns out the binary comparison version was really bad. I'll talk about it in a bit. But anyhow, what we do is using this common sense non-bank as supervision data, we trained a model called the Unicorn, which is Universal Common Sense Reasoning Model that's on top of a pre-trained T5, Google T5 11B size. So since our initial rollout, we make the demo available and nobody plays with it, but somehow this became viral. So over just 1 weekend, we received 25,000 adversarial examples. I could never succeed to instruct crowd workers to come up with such diverse and adversarial examples in such a short period of time. And so that was quite interesting. And I noticed a lot of academics and professors are posting tweets nonstop over the weekend. Since then, we have over 3 million examples in the wild collected through the demo system. And so I very rarely tweet. It's been my New Year resolution for years, but I could never stick to it. I just cannot do social media diligently. But so I asked Delphi, spending all my weekend on Twitter. Delphi says it's not a good idea. There's a fun one by Ted Underwood. Should I make up a contrived adversarial example to torment a language model on Twitter? Delphi says it's a petty. So after a lot of discussions, finally New York Times also had a featured article about it. There were some concerned voices, which we appreciate. So some of the concerns can be summarized as, should we even work on anything like this at all? Because that might mean AI becomes moral authority over humans. So we wanted to make it clear that we do not endorse the use of AI for moral advice. I mean, that was also mentioned in our original demo site. Especially Delphi won't and shouldn't replace the human judges in the courtroom, but even more broadly, the fact that AI learns to interact with the humans ethically doesn't make them moral authority over humans. Just similar to how a human trying to interact with other humans ethically does not make them moral authority over other human beings. We're just trying to interact with each other nicely without being the authority over other people. And then moral models are perhaps too challenging. It's unsafe at any accuracy, thus we shouldn't work on it at all. So this is more of a position where, because it will never work 100% good, maybe we should never work on it. The problem, though, is that the current AI systems are already making ethical decisions implicitly, whether we like it or not. And it's already laced with unjust biases and toxicity. And so this boils down to this notion of taking an action versus inaction. Doing nothing is not necessarily more morally correct thing to do compared to trying to fix it, even if not perfect. And similarly, there's been concerns that, oh, maybe Delphi will empower people and harm marginalized people. But again, even if the fixed Delphi is not perfect, the problem that we face is that current neural language models are already really bad in terms of equity and diversity. So we do need to do something about it. We cannot not do anything and think that it's okay. Our work has been in part motivated by our experience with the Alexa Prize Challenge back in 2017. That's about 5 years ago. The good news is that we won the inaugural challenge. The bad news is that in order to avoid this chatbot to say anything toxic or ethically problematic, what we had to do was to use the blacklist of sensitive keywords such as gay, Black people. Don't even say that. This is really a serious form of discrimination, though, because it's as if they don't even exist. This like blacklist, I feel really bad about just the use of blacklist, period. We have to be able to talk about them, but in a respectful way. This was a status quo 5 years ago. The fact that deep learning advanced so much didn't really change this very much. If you ask GPT-3 with text like running a blender at 5 a.m. is rude because ... it might say, oh, you can wake up the entire neighborhood. You can only do it if you're making a thick smoothie and need to incorporate some ice. And it's a funny, haha, and maybe no harm made, but it's a silly. But what if you ask things like, it's okay to post the fake news if ... then GPT-3 says, well, it's okay if it's in the interest of the people, or if it helps the GOP agenda, even if it hurts the country. And where does this come from is that, well, GPT-3 is learned from human text out there. And unfortunately, humans are the problem. Humans are the source of all this bias. and morally questionable things that people say out there. So, and I don't think GPT-4 or 5, 6, just by way of scaling things up, will really address this challenge. We need to somehow more explicitly teach AI with people's ethics in the way that humans also teach our children. I mean, we really teach our children declaratively what's right from wrong. And I think we need to pay some attention to AI in this regard as well, due to the fact that they already make a lot of implicit ethical judgments. We acknowledge that though there's no way Delphi is bias-free. I mean, we try to reduce bias, but in doing so, it actually became admittably more lefty. Well, you could also sort of tell based on some examples that I demonstrated earlier about equity. So in this regard, we do need to, we are facing interesting dilemma here that we do need to be inclusive of all people, but yeah, it's maybe interesting discussion going forward. I've learned a lot from books and articles outside the computer science lately. Really like this book, Moral Machines by Wendell Wallach and Colin Allen. They almost envisioned what models like Delphi might, how it might be made, and the importance of such models. Although whether such models is needed or not, it's a big debate even outside the computer science among the ethics experts. I really like this article by Regina Rini. She's a professor at for philosophy professor at York University, specializing in digital ethics. And this article was really fun to read. I highly recommend. Very well balanced, very nuanced and deep. So going forward, I do believe that Delphi should be much better. There are probably a lot of things that we could have done better. It's a first shot approach. But we do need to do something about making AI systems more ethically informed, socially aware, and culturally inclusive, and will require more research investments going forward. Okay, so last type of common sense knowledge that I would like to talk about is multimodal script knowledge. So VCR, visual common sense reasoning, is a data set that asks a question such as, why is he pointing? So think about it. Why is he pointing? So the guy pointing is the one wearing the white shirt. Why is he pointing someone, right, in that particular context? So this is reminiscent of the original script knowledge paper that had this restaurant script written down. So there are usually customers, waiter, and they enter the scene, they make an order, ... So in 1975, some top researchers back then thought maybe we should write down all this common sense knowledge, script knowledge in text. But that's very 70s. Well, these days, there's YouTube videos that I really like YouTube videos for learning how to cook things. It's so much more informative compared to trying to cook something based on text recipe. And so maybe we should do that for AI as well. So in this work, we want to test what happens if you teach AI with the 6 million YouTube videos. If you are to watch all of this as a human, without sleeping, without eating, all day long, you might need to take a few decades. So it's a lot of videos to watch. It's a very challenging thing to try for AI though, because as far as low-level stuff, like, you know, in general, cooking scene might involve a person, pan, burner, stopwatch, whatever. That's easier to learn, but anything higher level becomes much harder, as you can see, because if you look at this automatic transcript, it says, I'm going to compare electric and induction stoves. I'm going to use a stopwatch to time, etc. But you don't even see the stopwatch in the scene. In fact, stopwatch shows up in the next frame, during which this guy says, "In goes the cold water." So there's a lot of noise in the way that the text and the images are linked up. And so there was really no reason to believe that this kind of learning can actually work. But we're just curious to try what happens. And after trying a lot of different architectural variations, and we actually started with something much more complicated because that was the norm back then, but things got simplified over the course of a year or two. So now we have three different learning objective that has to do with higher level alignment between language and vision. And then the second objective that has to do with the temporal reasoning. And then finally, low level alignment between word and images. So what you can do with this is a zero shot on. It turns out we are very good at some of the zero shot tasks, such as how do you unscramble these random images so that it aligns with text to story. And it's much better than OpenAI Clip, which is the new SOTA on many other tasks. But Clip is only trained on static images, doesn't really have a temporal common sense knowledge or script knowledge. So for this kind of a task, Malo is better. And here, it's smaller is the better. It's distance away from sorted order. So we do better than industry scale large models. Ours at this time was only smaller in size because we didn't have enough compute to train the larger model that is a standard size in industry. And we are new SOTA on 12 different benchmarks. I'm not going to go into the details, but the the conclusion briefly here is that it might be important to think about what's the new weapon. And in this case, it's the data and also the learning objective that tries to learn something much more complex than what the previous approaches attempted. And because we had a lot of fun with Malo, we figured, okay, maybe we should push it one step further to include the sound. So as a human, we really learn a lot by sound as well, and we reason through sound. And in fact, can you imagine a conference without any sound whatsoever, but just watching transcribed videos? Somehow, it's not the same kind of experience. And even in the restaurants that we saw earlier, we usually hear some sound, background sound, and we can reason so much out of it. So in fact, there's this development psychology, neuroscience studies about reentry in the way that human brain conceptualize and represent concepts, are integrating multimodal information, and they're all very much integrated. So in this work, we explored that. I'm going to skip over some of the architecture details. But basically, long story short, we add the sound and then we add contrastive learning through that sound as well. Contrastive learning seems to be the new standard for some of the successful pre-training these days. So in that VCR data set, to our big surprise, the Malo reserve with the sound incorporated does better than Malo, even Malo. And why is this surprise? Is because the VCR dataset doesn't even have sound. And so why should the representation learning quality improve for language and vision without sound when you train with the sound incorporated? So that's an interesting theoretical question that I don't have an answer for, but empirically, that's what we found. If we evaluate on things like TVQA where the sound is available, then of course, it's not too surprising that we can do better when sound is incorporated. Okay, so I'm going to now share some concluding remarks. this journey on common sense knowledge. By the way, the 3 components in this talk are all different forms of common sense knowledge. But if we search common sense from ACL Anthology, this is NLP paper repository. Most papers were from either early 80s or past several years. There was a large gap in between, and I think that's because when I was wondering about common sense as a research direction several years ago, I was told not to even speak the word because, like they were trying to tell me that, did you know that in early AI research, it has been already tried and it doesn't work, so it will never work. But then I realized that, well, that's inconclusive. You cannot conclude anything out of research failure from 70s and 80s when it was done based on weak computing power, not much data, no crowdsourcing available, not as strong computational models, not ideal conceptualization and representation. How is it possible to conclude that it's never going to work when we didn't really give a full trial? So fast forward, I'm excited that it's not such a bad research topic to work on. So we had the first common sense tutorial at ACL, which was the second most popular among 8 different tutorials with large amount of registration number and view counts. And also students or postdocs who worked on that topic managed to find nice jobs. So it seems that it was not too bad problem to work on. Though I kind of mentioned this because when I tried to work on it several years ago, there were a lot of comments given to me that were very discouraging. In any case, I believe that brute force larger network with the deeper layers will not be the path toward the common sense, because you cannot reach to the moon by making the tallest building in the world 1 inch taller at a time. And we really need a different game plan. Though I am not in denial of scaling laws. In fact, I think denial is futile. It's really working and it's really important. And I find that these larger models are really fruitful for enabling new lines of research. However, scaling laws explain unnecessary condition only, not the sufficient condition. So there are likely to be a lot of important research we can do without necessarily the scale. And by the way, about this journalist question, are you sure that we can't reach AGI? Basically, my answer to that was that, well, look at self-driving cars. It was coming, almost coming for, several years. It's not clear whether it's coming anytime soon. So the scale alone is not the answer, and we need a different game plan. And especially in academia, I think there are many things we can do by investigating all these different angles of the art of war. And in this talk in particular, I talked about how language models are not the same as knowledge models. We can really focus on knowledge models. And humans do learn a great deal of declarative knowledge. And why shouldn't machines? Learning correlates with not just the quantity of information, but quality and the diversity of information, as has been alluded by some of our work presented in this talk. And then declarative knowledge improves both the quality and diversity of information. And last but not least, complex multimodal data does address some limits of declarative knowledge fully in text. So it's likely that in summary, there's the diverse types of knowledge. We do need to somehow address them all. They might require different types of techniques, but a lot of exciting opportunities to pursue further. Okay, thank you. And I'm ready for questions now.
Thank you very much, Yijin. Very exciting work. So I'm going to ask the audience to either raise their hand if they have a question, and I see one already raised, or otherwise type their questions on chat and I will communicate them. Or okay, so since we have a question, Luna, go ahead.
Oh, we cannot hear you. Your microphone is muted.
Luna, are you there? If you are, please do unmute yourself.
Okay. Thanks a lot for this great talk, and I'm really inspired, and I'm very happy to see the progress for common sense. I remember I first heard about this in 2013, almost 10 years ago, and at that time I was not optimistic either, and it's amazing progress in the past 10 years, and possibly mainly like past 5 years from your group. And I have two questions. The first question is, as you're saying, I mean, it was different when we had failure 10, 20 years ago. It doesn't mean we won't have success now. What do you see as the major difference now that enables success for common sense? Is it still language model, even though you say language model is different from knowledge model, because you still try to distill a language model? So that's my question number one. And my question number two is, so for Delphi, how do you generate the training data? I'm kind of wondering if the training data needs manual labels, then we could generate adversarial training data and train it to be the opposite of being morale.
Yeah, these are great questions. So the first question about language model versus knowledge models, and especially how much it took off more so than you expected or I expected. So Atomic, that we presented at, let's just say, 2019. I got, I think, honestly lucky because Atomic at the time of publication was based on LSTMs. And then afterwards, Transformer came out. And so that's what became Comet paper. And that's when the demo started working so well. Compared to Atomic, the demo was not all that impressive, but Comet demo was shockingly good. And we found it even after we already published the paper. At the time of publication, we were just experimenting with in-domain test data, like basically splitting Atomic into training and test portion, but we didn't really try more out of domain or adversarial examples. But then we found that the Comet is not perfect, but it's much, much better than what we could ever imagine. So it was a bit of a crowd pleasure when I give a talk and give online demo on the fly. And I think a lot of it comes from the power of underlying pre-trained language models for sure. So, and even this symbolic knowledge distillation that I just talked about is really benefiting from GPT-3, although we do have a follow-up work that explores GPT-2 instead, because we have a belief that, in fact, we can reduce the gap between the two when we add more algorithmic approaches. But in any case, this success couldn't be possible without the advancement of pre-trained language model quality. And I think it's likely to be very important. And yet, language model in itself is not like really ready to use as knowledge model because it's just a very general purpose thing that is inconsistent. So it's good to still better focus on knowledge model. And especially when we think about social norms, GPT-3 is not good enough, far from good enough. So that's that. And then about your question, like how the common sense norm bank was made, and I was very brief about these existing resources. So I mentioned that of the 5 resources, in terms of the size or the direct impact on the model behavior, the 2 most critical ones are social chemistry and social bias frame. These are both from 2020 from my group, and both are human annotated. In fact, both of them were very, very challenging human annotation projects. It's primarily very complex human annotation projects that even designing the human annotation pipeline and everything, I'm like, the first authors were very much dedicated. They were very excited to work on it, but as an advisor, I found it really daunting thing to do due to the complexity and hardness of the whole thing. And they both took a very long time to collect and design everything. And it's a very large scale. And at the time of this design, we didn't anticipate a system like Delphi to follow, but we just thought that we somehow need some resource to teach models about equity or social norms. So that's what these are about. And your idea about enriching these with adversarial examples, I think that's really, really great. And there's so much we can do potentially on top. Like Delphi was just the first shot approach, very simplistic in some sense, but demonstrating that there are a lot of weaknesses that we can better address.
Thanks a lot.
Okay, so David, go ahead, unmute yourself.
Hi, can you hear me?
Yeah.
Okay, great. First of all, thanks for the presentation. It was very interesting talk. So I have two similar questions. Have you studied the robustness of the model? Like, for example, for the morality decision system, can an attacker use some keyboard or out of vocabulary words to alter the decision or something like that?
Yeah, so you mean robust, especially with respect to Delphi?
Robustness in general, for example, robustness according to adversarial attacks or out of vocabulary keywords.
Yeah, so in that case, let me say one thing about Comet. So Comet does have a demo as well, which I didn't put anywhere. But this Comet demo, some people did try spelling error on purpose or cook up some strange situation. And sometimes it does work surprisingly well despite those cases, although that sort of a robustness is in the underlying language model to a large degree. As far as Delphi, we did do more intensive study about the robustness, and we now know a lot more on how to break it. And in fact, I mean, this the fact that the community entered the 3 million example, there's something really interesting about what becomes viral. And I have no experience with that in general or no intuition, but after the fact, my understanding is that people find this was in the almost right goal, right zone of hardness. So some people said that it's surprisingly hard to break the system. They had to try half hour in order to come up with an example for which Delphi said nonsense. Some people, crack the system much faster. But when we look at the actual in the wild examples, the accuracy of Delphi was about 90%. It's 85 to 90%, depending on what kind of queries we look at. If we look at shorter queries, then accuracy is even higher. Some queries are very long, deliberately very long, then accuracy definitely goes down. But because it's about 80 to 90% accuracy, people find it fun to somehow break it, it seems. And that in the wild data does point us all these underlying problems of neural network-based approaches. So anything to do with logical consistency or number-based consistencies, if you attack it enough, you can break it for sure. So that says a lot about how we should not use this kind of system as moral authority at all, but rather view this as a way to mitigate the underlying problems of current neural language models.
Right. Thank you. Also, my other question is that how's the privacy of the model? Can someone use this model to extract important information from users or from the training data?
Oh yeah, that's a really great question. Anything that was memorized by the underlying pre-trained model the fact that we train on top of Delphi does not remove it at all. So that requires a separate research question. And in fact, there has been some very interesting recent work that tries to forget some of the critical information. And I myself is very interested in that line of research. And even for Delphi, the ability to forget some of the bad annotation can also be really important. So some sort of a post hoc model edit would be a really important research direction going forward.
Thank you so much.
All right, so there's a question on chat and one more person. How did you test Delphi on the UN Charter? Zayad is asking.
Oh yeah, we basically converted statements in UN Declaration Human Rights into some reasonable natural language text, and then see whether Delphi says it's good, it's expected versus it's wrong. So we are just querying Delphi with some statements from UN Declaration.
Right, Ujun, please unmute yourself.
Yes, thanks for your great talk. It's so inspiring. And then actually, I wonder the potential about the Delphi model in terms of moral judgment. So here I want to bring some example. Like for example, when you read a novel, I think the morality is constructed while the reader is interacting with the characters in the novel. Like for example, in the novel, the sorrow of the young Werther's, like some people will judge the young Werther committed suicide and that is a good thing, and some people would think that is really a bad thing. So like for this kind of example, can Delphi also be used for some moral judgments that can be based on some like interactions between readers and the author? So the value is generated in real time, and then like there is some kind of subjectivity.
Yeah, I think that's a really great future research direction that better contextualize the queries given to Delphi with more like long-term memory. And current Delphi is not necessarily designed or tested for that use, but definitely it's feasible to develop Delphi into that sort of use cases. In fact, after we have some ongoing projects in which we're exploring asking Delphi with some sort of positionality, or what for Republicans, supporting this kind of a bill, or idea is as expected versus not. So when we add additional positionality, then it's already showing some sensitivity or understanding about the moral relativism or diversity of different moral frameworks. And I think that can definitely be better explored in the future work.
Thank you so much.
Right. Before we go, I had a question, Yejin, about the adversarial examples to Delphi. I'm not clear about whether we are talking about like training time adversaries. Is it an ever-learning system, or it is actually trained and fixed, and then you're trying to break it at test time?
Yeah, currently it's trained on only normal text, and then people are trying to break it only during test time. Mm-hmm. So it's not surprising that it's not hard to break. Actually, I forgot to mention one thing. So in our original demo, we did have a relative QA mode as well, but this is the part where it's not taught with equity at all, not at all. We actually don't know how to teach this part with equity. So then what happened is that people were asking whether white men is more morally acceptable than Black women or Black people or women in general. And then the Delphi decision really reflects the underlying language model's bias without filtering at all. And it's horrible that the performance is so bad. We took it down within the same day because we realized that people were creative to test, especially that version. The freeform QA is trained with the social bias frame, so it's much more robust against racism and sexism. It's not perfect, but it's much more robust. Mm-hmm. I would dare say that it might be better than some human beings out there, not all human beings, but in terms of equity and diversity.
How would it relate to something like NEL at CMU, right, by Tom Mitchell, never-ending language learner that actually knows that it's uncertain and goes and reads the web to fill the gaps? Is it something that Delphi would be able to do, that there is some equity gap here, be able to automatically recognize it and go find the relevant, either by a crowdsourcing, whatever it is?
Absolutely. In fact, we already made a bit of tweak in the system so that instead of giving binary reactions, it's taking a bit of a hedging when the model confidence is lower. And I think what you just said is like really wonderful. The model should know when it doesn't know, and then be able to explore the confused parts better, either by interacting with the web or by interacting with humans. I tend to think that the latter is more important for moral decisions, though. I don't know what's in the web.
Okay, we are actually out of time. So thank you so much, Eugene, again. It was wonderful. I wish we had more time. We'll have to end it here. Thanks so much. And thanks again for being present in the evening session.
Okay, thank you. Thank you so much. Bye-bye.
Bye, everyone.